What's your thought on week 11 content and week 12 content? I mean, did you find as difficult or easy or interesting? I mean, what's your honest review regarding the content of?
Confusing.
Very difficult to understand.
Confusing, so not difficult to understand.
Okay, why did you find that? I mean, where you are getting confusion?
So that alpha value, when to reject, when to accept, even
Mm-hmm.
that stuff, alpha and beta.
Alpha and beta. Okay, first of all, then okay, let me quickly go through then. Okay, then I will give you maybe some idea. I will start. Let me share my screen. Okay, so any one of you can explain me what do you mean by the hypothesis testing? Like, what's your thought?
Manoj, this side, sir. Very good evening.
Yeah, good evening.
Actually, sir, we, for example, for a general belief, we see that if, for example, if you think that this is the condition, that's a general opinion. For example, uh, the number of student in the particular test are not are following the honor code. That's a general perception.
Mm-hmm.
We can make this as a null hypothesis that is
Mm-hmm.
generally believed, but we have a doubt that whether it is correct or not. So we can check statistically whether this is correct. We make an alternate hypothesis that this is not correct. So we can check this statistically. So that is what I got, that whether null hypothesis is correct or not, or alternate hypothesis is correct, that we can check statistically. One particular condition, one belief which we think that is
Mm-hmm.
there, that is generally considered to be the null hypothesis, and that is the alternate hypothesis. This is what I got.
Okay, correct. Any other thought? Any other people? No one. So those who have watched lectures, see, don't be any. So you can simply. I just wanted to hear. I mean, what kind of like at which level you got the idea and all. That's right.
Null is like established belief, and means it is something that it is assumed for that population parameter. Like we assume that it will have this kind of probability, and then based on the samples which we get after sampling it, we decide some alternate
Mm-hmm.
evidence for like alternative hypothesis that could be possible.
Correct. Let me give you one more example. So, okay, basically, idea when this hypothesis testing is, so if you focus on the word hypothesis, right? So you can understand whatever the claim you are going to make, right? You are going to test that claim. Okay, whether you are going to reject that claim, you are going to accept that claim or not. Okay, all right. So suppose I'm saying, suppose you are owner of a manufacturing company. Let's say you are owner of like manufacturing in your company you are manufacturing medicine bottles. Okay, let's say medicine bottle you are manufacturing. So the claim from your side is, let's say you are saying uh, on an average the I mean the liquid in medicine bottle is, let's say you are saying 100 m. Okay, this is your claim. All right, so far is this fine? This is the your claim,
Yes.
right?
Yes, sir.
You are saying the on an average this is 100 ml, right? But suppose I'm a market researcher, or you can say analyst and all, but I felt or I heard or something, I felt like you are underfilling the bottle. All right, so underfilling the bottle means what? My mu will be less than 100 ml. Yes or no?
Yes.
Yes, sir.
Correct. That's my you can say I felt. So what I will do, basically this will be your null hypothesis, which is default claim, you can say. Okay, this is default claim, you can say, or default assumption or claim, and this is alternative. Okay, sometimes it's represent H1 or HA, anything is fine. So thing is, So what I will do for to test this claim or to test this hypothesis, right? Okay, to test this hypothesis, what I will do, I will collect some sample, yes or no? And based on this sample data, I'm going to make some, I'm going to make conclusion or regarding this, whether I'm going to accept this claim, basically you can say whether I'm going to accept this hypothesis or claim, or whether I'm going to reject this hypothesis or claim. Okay, so are you getting my point? So this is the key idea behind hypothesis testing. You made a claim. Okay, for to test that claim, I will collect some sample data. Based on this sample data, I'm going to reject that claim or accept that claim at a at a particular level of significance. That means, suppose I'm saying significance level is 5%. Okay, what do you mean by this 5% level of significance? Any thought?
So we can say the probability of rejecting the null hypothesis when the null hypothesis is true.
Yeah, that is the definition. That's correct. That I'm not denying your answer. So I'm just wanted to intuition behind. What do you mean by this?
How confident are we? Basically, it tells us how confident are we while making this statement.
How minimum the error is between the
Correct. Same thing. Confidence and all basically. Okay. So basically, you can say basically you are okay with some sort of error, right? Yes or no?
Yes, sir.
Okay, so basically this alpha will help you to decide. Someone told this confident and all. Okay, so this will be this will help you to decide. So basically, let's say if you go by the definition, right? So alpha is what? If you see the definition, probability of, let's say, rejecting H naught when H naught is true. So whenever you are saying given that H naught is true, then you have to check what is the probability of rejecting your H naught. Okay, so this is the definition of your alpha. Okay, let me draw a graph. Maybe that will give you the some sort of idea. So okay, alternative hypothesis can be greater than this part. This can be less than, greater than, or not equal to also. Yes or no?
Yes, sir.
Okay, let me draw some graph. Maybe that will give you the idea. Suppose this is my there is some background noise. Yeah, thank you. Just basically this graph should be bell-shaped curve. Okay, just treat this as a bell-shaped curve. Okay. Okay, suppose I'm saying I have a Z standard normal variable. This is, suppose this is mean 0. Okay, and suppose I'm saying this is my Z alpha, or you can say this is my let's say critical value. I mean Z alpha you can say, or C you can say. I'm writing CV as a critical value. Okay. So what I'm saying, if my test is like this, okay, suppose this, okay, this is my
So
alpha.
what is Z alpha?
This is just a notation for critical values. Don't worry about that. Okay, we are not. I mean, sir took as a C. I think
No,
maybe.
I'm asking about the Z alpha. I'm not asking about the CV. Critical
No,
value is fine.
Yeah, that is the same notation for critical value actually. Z alpha. Are you getting? So Z alpha is just you can say another form of C, but we are not using here. Actually, I have used earlier, so that's why it was in my hand.
Okay.
Yeah.
Sure.
So this is your alpha. So this alpha is when your null hypothesis is right side tailed. Correct?
Yes.
I mean, there is, suppose H naught I am going to test for mu. Let's say mu is some value, specific value mu naught, and alternative is something mu is greater than mu naught. Okay. Then this is the something this will represent the 5%. Okay, and remaining area will be 95%. Are you getting my idea? If you are taking alpha as a 5%, then if alpha is you are taking 10% level of significance, then it will be this acceptance region will be 90%. So whatever the values of your sample data, if that sample, let's say X bar, for example, for sample mean, if it's lie between after this point, then you are going to reject. Is this clear?
yes, sir.
Yes.
Essentially, it is the rejection region.
Correct, correct. Rejection region is 5%. If you are taking alpha as a 5% particular, you can take 10% also. But mostly we are taking 5%. It will be given in your question whether you have to take 5% or 1% or 10%. What about left tail test? So suppose this is standard normal curve and this will be, let's say, minus CV. Okay, if your, and this will be my alpha. Basically, I'm saying this is my rejection region. If my x bar, or that value of test statistic will lie between in this region, I am going to reject my null hypothesis. Is this clear? So here null hypothesis will be, let's say, mu equal to mu naught, and alternative will be mu is less than mu naught. Is this clear?
Yes, sir.
Okay.
Yes, sir.
If you have two tail test, I mean, it's not clearly mentioned whether you are this your null alternative is greater than or less than, then what will be your test? Basically, you are going to say it's not equal to, right? So if it's not equal to, that means suppose this is your C and suppose this is minus C, for example, and peak
Sir,
will be at 0,
sir,
right?
sir, 1 second.
Huh.
So just in the example you are quoting about the medicine having 100 ml of fluid in the bottle, okay, there they are claiming that we will have 100 ml.
Correct.
And alternative, is it going to be not equal to 100 or is it less than 100?
No, it depends on what you are thinking. Suppose as an analyst, I felt you are underfilling the bottle.
Correct.
Okay. Underfilling me, it will be less than. Okay.
Yeah, because not equal to 100 doesn't make sense, because if it is 101, why should we worried about? Right?
Correct. Something like that. Yeah. So it depends on what kind of claim and what is your suspicious. I mean, what's your suspicious about that claim? Okay. So accordingly, your alternative hypothesis will be there. Fine.
Yes, sir.
Yeah. Okay. So if this is the case, and this is two-tail test. Two-tail test means you are saying, let's say h naught is something mu equal to some specific value, and alternative is saying mu is not equal to mu naught. Okay. So that means your rejection will be what? Whether it can be this one or it can be this one. Tell me whether, what should I write? This is, correct me. I can write this as alpha by 2 or not, if I'm talking about at alpha level of significance. Right?
Yes, sir.
Right. So basically both sides alpha by 2 will make you alpha only, right? I mean, at 5% level of significance. I mean, in two-tail test, you can reject this side or you can reject this side also. Is this clear? And something you have seen, if you have right tail test, right, then when you will reject your H naught, can you tell me the test? You will reject H naught, your H naught,
if it is greater than
T is
certain value
greater
C.
than some C, right? This is something we have defined, right? And here you will reject your H naught when, if
T is less than
what?
C.
C or minus C?
Minus
C, right? This is minus C. Okay. Because left hand side, so this is 0, right? Left hand side it will be negative, right? And here what will be your test? You will reject your H naught if modulus of T is greater than C. This means T is greater than C or T is less than minus C. Correct?
Yes.
This is something we have seen, right?
Sir, is it possible that you have written alpha by 2 and alpha by 2? So is it possible that I can have in non-uniform alpha values at both the sides, like alpha by 3?
So this one second. So this is symmetric curve, right? Both will be equal. Okay.
Okay.
Yeah. So is this okay? Till now, this is it clear, the meaning of one tail test, right tail test, left tail test, and two-sided test? Yes. No. Any thought?
Yes, sir.
Okay. So basically, what is the something we have to do for a general hypothesis testing? Let me write the steps and then I will come to that. So to test the general hypothesis testing, right? So what is the procedure? Basically, first step will be, you will define your null hypothesis. Okay. Then you will define your alternative hypothesis, and then there will be one significance level. Okay, level of significance. That means, based on this, basically what it will give you the reliability of estimates, and it will give you the kind of permissible risk. I mean, you are okay with 5% risk. That is something. If you are saying alpha is 5%, that means you are okay with 5% risk, and you have confidence of 95%. Is this clear?
Sir, 5% risk is same as 5% error, or they are
Correct.
different?
Yeah, error. Risk means you are
Yeah.
okay with 5% risk. Okay.
5% error. Yeah.
And next step will be you will define your test statistics. Okay. And fifth step is whatever the conclusion will be there. Okay. So based on here, right, whether it's a right tail or left tail test or two-sided test, you will define your test statistics, right? Whether you are going to reject your when value of t is greater than c, t is less than minus c, or absolute value of t is greater than c, and based on this, you are going to make a conclusion. Okay, so some rough idea is clear regarding the steps of hypothesis testing.
Yes,
Now,
sir.
sir, can you take some example and try some?
Yeah, I will come to that. I think this is something it has been discussed in week 11 already. I'm just
Okay.
recapping the thing. Okay. One more thing I would like to ask you. So something we have seen alpha. Okay. This is something we know as a type 1 error also. Correct?
Yes, sir.
What is this? We saw the definition. I will say when probability of rejecting H naught when H naught is
It's true.
true, right? And beta was defined as something type 2 error. And what is the type 2 error? Probability
Except
that,
H naught.
Accepting
no.
H naught given
Except
is true.
And given that H1 is true, right? So based on this, I'm going to give you a scenario. Tell me, how should you, how will you write the alpha and beta? I mean, type 1 error and type 2 error. For example, I'm saying, suppose there is a manufacturing company again, and there is, you are manufacturing some product, and it depends on the bad quality and good quality also, right? I mean, suppose you are manufacturing the product, right? So that might be of good quality as well as of bad quality, right? That's possibility. Okay. Suppose I'm writing probability that I'm going to reject that, reject a lot, or reject that item when it is good. So what should I write for this? Alpha or beta?
Beta.
Alpha.
Just think a bit.
Huh?
Alpha.
Alpha.
Oh, alpha. Yes,
Alpha, right?
is alpha. Correct.
You are okay. What will be your H naught here? Means that product or that lot is of good quality, right? That is the default claim, right? And what you are saying, you are rejecting that lot when it is of good quality, correct? So what is this? So one terms here, I mean, that is something is not discussed here. Can I say this as it's a producer's risk? Can you relate with real life now?
Correct.
This is
Yes.
the producer's risk, right? That
Yes.
lot has been rejected, even that was of good quality, right? That is the producer's risk. Okay, that is something it's not discussed here, but I'm just informing, giving you some information. If I'm writing that probability that accepting that lot or accepting a lot of that items when it is bad quality, this will be beta. Yes or no?
Yeah.
Yes.
Yes.
You are
Correct.
accepting that lot when H1 is true. That means it was of bad quality. So what is this? Can I say this is consumer's risk?
Yes. Perfect.
Yes.
Yeah.
Are you
Yeah.
able to relate, right? So you
Yes.
have accepted that item even that was in bad condition, bad quality, right?
Yes, sir.
Correct. Okay. So some sort of idea is clear now. What is the role of your alpha and beta in real life now?
Yes. Yes. Making sense.
Yes, sir.
Okay. So one more thing was there, p value. See, I should discuss in ideally week 12, but I will move to the week 12. Don't worry. So what is the p value? I want to hear from you. Whatever the things which you understand, just let me know. Don't worry about wrong, right. We will discuss.
P value is basically the border case beyond which you may tend to you may tend to accept, though it is you may tend to accept. It's a border case of alpha, sir. P values.
Yeah. Anybody else?
Hello.
Any thought?
Mm,
So peak will be at mu only, right? Suppose I'm saying this is my critical value C. Okay. So this area which is I'm highlighting, this will be, suppose I'm saying this is alpha, for example, right? Suppose it may be the 10%, 1%, 5%. Suppose this is alpha. Okay. If your T, for example, suppose will lie in this region, you are going to reject your null hypothesis. Seems good. Sounds good or not?
Yes, sir.
Now, what is the p-value? If I will explain the definition of p-value. So p-value is nothing but it's a lowest significance level, or you can say lowest significance level alpha, at which the null hypothesis will be rejected. Okay, the thing is, this will give you the lowest significance alpha. Suppose, for example, this is, suppose I'm saying this, there is one value C dash. Okay, C dash, and this region, this which I'm highlighting, this will be the p value. Are you getting? So alpha, suppose you are dealing with alpha only, then if whatever the based on your test, if your x bar is like between, or value of t is like between here also, you will reject, right? Correct or not?
Yes, sir.
Let me show you. So this green region, then you will reject. But the thing is, p value will give you the lowest value at which you will reject your H naught. Okay, fine. Clear? Any doubt?
No, sir.
Okay, clear. Okay, then if you are okay with it, then okay, one more thing. What you will define your how will you define your H naught? I mean null hypothesis, if you have been given a single sample. I mean in week 11 you have done with we have deal with single sample, right?
Yes, sir. Single sample.
Single sample, right? So the thing is, how will you define for your H naught for single sample? Just tell me in terms of, in general. Suppose I'm saying X bar, this as a statistic. Okay. Terminology. Mu, I mean parameters of population as a, let's say I'm saying parameters. How will you define your H naught? Okay. Let me write then.
sir,
Maybe.
question is not clear, sir. If you don't mind.
Okay. So my question is, suppose we are dealing with single sample, right? You don't
Yes.
have two samples, then what will be your H naught in general? So you are writing mu is equal to mu naught, right? I mean, if you are dealing with mean, correct? So
Yes, sir.
what I can write, basically H naught will be, I will write the sample statistic, okay, does not differ significantly from the hypothetical value of parameter value, or you can say parameter. So what I mean by this, sample statistic does not differ significantly from the hypothetical value of parameter means, suppose what is saying, suppose whatever the X bar, let's say you are going to calculate with sample data. So what I'm saying, there is not significant difference between this, the mean which you have calculated from sample data, and the something which you are saying a hypothetical value about mu. Let's say you are saying on an average you are going to fill 100 ml of bottle, right? Then what will be your claim? I mean the claim, what will be your H naught? based on sample data, you will be interested to find the mean which you are going to compute from sample data is I mean that is not significantly different from this mean. Are you getting my point? Yes. No?
No, sir, I did not understand.
Okay. So suppose I'm writing h naught as a, let's say I'm saying mu is equal to 100 ml, right? For example. Okay. So
Yeah.
what does this mean? To test this claim, I'm going to check from sample data,
Yeah.
right? From sample data, suppose I'm calculating value of x bar.
Correct.
So what I would like to test, there is no significant difference between the value of this and in this 100 ml, means hypothetical value of my parameter. Now is this
Okay.
clear? Right? Are you getting this part? Right? So
Yes.
yeah. So similarly, you can, okay, this is for mean. For example, if you want to test for variance, then okay. Are you getting? So suppose let me come to this part. Okay. So suppose your question is you want to test for mean. Okay. There is a test for mean. I mean your hypothesis. So this is hypothesis in under hypothesis testing. So based on different scenario, right? You are going to use different test statistics. Yes or no? Suppose you are going to test for mean. Test for mean means suppose your h naught is something. Let's say mu is a specific value of mu naught. Let's say for that 100 ml case. Okay. You are saying mu is equal to 100 ml. Okay. So now what is the case? I'm going to test for mean here. Yes or no? This is test for mean.
Correct.
Now, so what you have to check, if your population variance is known to you, then you will use Z test or G test. Correct? And so this is the situation. If population variance is known to you, population variance is known to you means suppose question is given like this, you x1, x2, let's say xn are IID, normal, mu, comma, let's say 36. And h naught is, let's say mu is equal to 10 and ha is mu is greater than 10, then at let's say alpha equal to 5%, test your hypothesis. So you can see here population variance is known to us, right?
Correct. 36.
Correct. 36 is given to us. And which test I am going to use? I will use this right tail test, right? Based on this h naught and ha, right?
Sir,
Yes.
yeah, this table which you're showing here now, will that be given for the exam?
Yeah, I think I have discussed the same yesterday also. Yeah, this will be given.
Okay.
Yeah. Okay. So are you getting my point, right? So here sample variance is given to us. Sorry, not sample. Population variance is given to us, right?
Yes, sir.
Yeah.
Okay. If I'm saying, suppose in the same scenario, I'm saying h naught is mu is equal to, let's say 10. ha is mu is, for example, greater than 10. And in here I'm saying x1, x2, let's say there are and IID samples, let's say from normal and with mean mu and some unknown variance sigma square. Okay. And there are some sample data is given to you. Let's say some 98 something, let's say some 10 sample data is given to you. Now, based on this hypothesis, you have to test for mean, right? And you can see the population variance is not given to us, right? It's unknown to us. Then what you will do? You will go for t test, right? And if you see in the formula in the denominator part, it's a s by root 10. So s is what? Sample variance, and this sample variance you will calculate from this sample data. Okay. While in the previous scenario, you can see this is population standard deviation, and this is something it's already given to us as a sigma square is 36, so sigma will be 6. Is this clear? The difference is okay.
Yes, sir.
Are you getting my point, right?
Yes, sir.
Okay.
Yes, sir.
Sir,
So,
what is hello, sir?
uh-huh.
What is that C, sir? Rejected region X bar greater than C.
C is the critical value which you have to calculate.
Oh.
Okay, and based on that, you will decide whether you are going to reject your hypothesis or accept your hypothesis, right?
Is it a Z alpha by 2 into
No, no, no,
sigma by root n?
no, not that is C. C is something you have to calculate. I think you have you watched the week 11 lectures.
Oh.
No, right? Okay, let me take you. Let me tell you one example. Then I will come to that. Okay. Okay. One more thing. How many of you are okay with week 11 content? Because today is about week 12, so I would like.
I am fine in general, sir. In general, I think I'm okay, but still I need to master it. That's a
Okay,
different story, but I'm
that
overall okay.
that will come by the practice.
Yeah, yeah.
Okay. Okay. So, okay, one more thing. Then let me take some examples. So everyone is okay with the formulas and all,
Yes, sir.
Yes, sir.
right? The formula which already discussed there. Okay. Let me take some examples. Okay, maybe that it's in week 11. It should be week 11.2. I just wanted to check. Yeah. Okay. Let's try to do this question. Okay. So consider one sample X follows normal mu comma 9. So can you tell me this population variance is known to us? Population means
Yes.
the
Yes.
Yes.
from where we are collecting the sample. What is the null hypothesis? Mu is -3 and alternative is mu equal to 3. Correct? This is given to us. Okay. So consider a test that reject H naught if X bar X is greater than C. Okay. Basically, I think it should be X bar for some constancy. So what is the significance level of the test? Okay. So significance, how will you define significance? Alpha, right? Alpha is what? Probability that rejecting H naught when H naught is true.
Correct.
And when you are going to reject, you can see in the question it
When
is given
X
that
is greater than C.
X is greater than C. This is H naught. And what is the H naught? You can see H naught is given as a mu equal to -3. Correct? H naught is what? Mu is equal to -3. So
Yes.
alpha will be what? So here, what is the next step? Whenever you are solving this kind of hypothesis questions related to hypothesis testing, right? Convert
Need
into
to.
standard normal variable, right?
Yeah.
Only then you can find the fz values, right? So
Correct.
to convert in a standard normal variable, so x follows, it is given that x follows mu comma 9. Then what is the step to convert in standard normal? I have to subtract the
X.
expected value and divide by the standard deviation of that, right?
X. Yeah.
So if you'll do like this, what will be x minus mu? What is the standard deviation of x?
3.
3 greater than c minus mu divided by 3. See, the same thing we have to do on both sides of this inequality, right?
Yes.
So this will be z greater than c minus mu divided by 3, given that mu is equal to -3. What is the value of mu? -3. So see, this will be c minus -3
-3.
divided by
3.
3. So this will be probability G greater than C plus
C plus
3.
3 by 3.
To convert in FZ, I should write 1 minus probability Z less or equal to C plus 3 divided by 3, because f of Z is what? Probability that Z less or equal to small z, right?
Correct.
So
Correct.
Yes, sir.
it should be less or equal to sign. So this will be 1 minus FZ of C plus 3 divided by 3. Is this clear?
Yes, sir.
Yes, sir.
Okay. Now next is, what is the power of the test? So power of the test is nothing but it's a 1 minus beta. We have seen beta was probability that accept H naught when H1 is true, correct? Or alternative is true. So 1 minus beta will be probability of rejecting H naught when HA is true.
Yes.
Correct. So probability when you are going to reject H naught when this X is greater than C. It's given in the question already. And what is the HA? You can see HA is
3.
mu equal to 3, right?
Mu equal to 3.
So it will be mu equal to 3. Now I have to convert in standard normal variable. So it will be x minus mu divided by 3 greater than c minus mu divided by 3, given that mu equal to 3. So it will be probability that z greater than c minus, what is the value of mu? It's the 3 divided by 3. So it will be 1 minus probability that z lesser equal to c minus 3 divided by 3. It will be 1 minus fz of c minus 3 divided by 3. So you can say this level of questions. All right. Okay.
Yes, sir.
Okay. So let me come to this part. Uh, okay. So this was for mean, right? So if you want to test for variance, okay, then there is a test called chi-square test for variance. Okay. I mean, to check the, I mean, your null hypothesis about like this. I mean, you want to check your sigma is equal to sigma naught or not. Okay. At the same end, suppose h is defined as, you want to check whether your sigma is greater than some specific value of sigma. So sigma naught can be here 4, 16, anything. It will depend. It will give you, it will be given in your question actually. So what will be your test statistics? So t is nothing but n minus 1 s square divided by sigma naught square. So this will follow chi-square n minus 1 degree of freedom. Okay. So anyone can you tell me what do you mean by the degree of freedom? Any thought?
The directions in which all directions can it go wrong or something like that, or
Okay.
just wild guess.
Yeah, fine, fine. That's not problem.
Independent.
Independent what? Okay, so let me write the meaning of degree of freedom actually. That's not, we shouldn't go in that deep, but anyway. So basically degree of freedom is nothing but it will tell you the number of, you know,
Independent values.
correct. So independent variates. Okay, here we are dealing with variates, which basically help us, which make up the statistic. So what I mean by the statistic, that is, for example, let's say you are saying, you know, chi-square statistic, z statistic, or t statistics. We are defining, right? T is equal to something. Okay. So this is known as degree of freedom. So you can say the number of degree of freedom, right? So this is equal to total number of observations minus number of constraints, right? Is there any constraint or not? Okay. So that will give you the degree of freedom, right? You can focus on the word freedom here, correct? So basically, if you see, if I'm writing for this formula, right? N minus 1 s square divided by sigma naught square. This is follow chi-square n minus 1, because if you see, so sigma naught square is given to you, right? So what is the formula of s square? N minus 1 s square will be basically summation I to n xi minus x bar square. Yes or no? The numerator part. Yes.
Yes, sir.
Okay, what is the chi-square? Chi-square with 1 degree of freedom. How will you find the chi-square? Is there any idea?
Don't know at all, sir.
Okay, so chi-square is nothing but if you have one standard normal variable, right? Okay, so if I'm saying z square, so this will be chi-square with 1 degree of freedom, because I have only one variable. Suppose you have two standard normal variable, let's say z1 square plus z2 square. This will be chi-square 2 degree of freedom. Okay, so square of standard normal variable is nothing but chi-square with 1 degree of freedom. So the question is, why, if you will add n standard normal variates, right? So this will give you the chi-square with n degree of freedom. So I'm not going into the derivation behind this and all. If time allows, I will do this. But the thing is, I want to explain why this n minus 1. So I told you, basically, if you see this formula, right? If you see according to this, this should be chi-square n, right? Because we are adding n standard normal variable here. Yes or no? If you see this formula, what I'm doing, xi minus x bar divided by sigma naught whole square, correct? So we are subtracting the mean, dividing by the standard deviation, and then square it. So this should follow chi-square n, right? By this definition. Are you getting this definition?
Yes, sir.
So why we are doing n minus 1? Because of we don't know x bar, and there is one constraint. We have to calculate this x bar from the sample data. So I will subtract one constraint. So total observation is n. I will subtract that one constraint. That will give me my that will give you the degree of freedom. That's why we are doing is n minus 1. Okay. So this is the formula. Okay, so we have to focus here actually the question here, but yeah. So if you have left tail test, then my t will be again n minus 1 s square divided by sigma is sigma naught square. But thing is, when you will reject, I will reject when s square is less than c square. So what is the s square? This is sample variance. Yes or no? So if you see, in case of mean, what we are doing, we are dealing with the if sample mean is less than some c here, and here is sample mean is greater than some c. Here we are dealing, we have to check for the, we have to test for the variance. Then we will do sample variance is greater than c square, sample variance is less than c square. Similarly, in case of two tail test, s square is greater than c square and s square is less than c square. While you can see in case of mean, what we were doing, mod of t is greater than c or not. Yes or no?
Yes, sir.
So can you tell me what is the like reason behind this? Like s square is greater than c square. Why not minus c or something like this? Because in case of mean, we were doing the s square is greater than, right?
A square is always positive.
Square is always positive. Okay. Is there anything else?
It's a variance. So
Oh, sir, it is variance, sir.
Variance.
Okay. Anything else? Okay, let me show you something. So if you see the graph of chi-square test, right? So this is something like this. Okay. Now it's clear. So you will deal with whether s square is greater than c square or s square is less than c square. While if you see the normal curve, it's let me show you standard normal distribution. So this is two-sided, right? So peak is always mu is equal to 0. This is symmetric curve. Okay. So now, as of now in stage 2 course, we are dealing only for two kind of tests. First is test for mean, and second one is test for variance. In case of test for mean, we have to check whether if the population variance is known to us, I will use Z test. If the population variance is unknown to us, I will use T test. And if I'm going to test for variance, I will use chi-square test for when you have only single sample. Okay. So far, is it clear?
Yes, sir.
Okay. So will you able to do the questions?
Yes, sir.
Yes, sir.
Okay. So should I proceed with week 12? I mean, till now, I think I was discussing only week content of week 11. Or do you want me to do one or two questions of week 11?
Yes, sir, please.
The important questions of week 11.
Important else what?
Which is going to be present in interim exam.
No, that is something you have to prepare at. Everything we can't do here. Okay. So the one thing we can do, I can explain the concepts and all everything. Okay. So the rest thing you have to, I mean, basically you have to do the practice from your end. So the one more thing I can assure, if we are whatever the questions we are doing here, what kind of questions is going to be basically helpful for you. Okay, no worries. So if you see this question, right? So okay, how will you proceed? First, about tell me whether you will use Z test or T test.
Z test.
Z test.
Z test.
T test.
Jet test.
No, okay. If you are saying jet test, then why? If you are saying T test, then why?
Sir,
Sir,
the sigma.
population variance is given. So Z
Population variance is given to us, right?
yes.
And only mu is unknown, correct? So, and we have to test for mu. First of all, this is mu is not equal to 3. Then what I will do? I will
Two-tail test we
use
will.
a two-tail test, right? So to proceed with two-tail test, how will you do? Okay. First of all, let's write. Okay. So you will tell me how should I do? Okay. Okay. What should be my very first step? So so this is activity 11.7. So question 1. So what is the H naught? Mu equal to 3, correct? And what is the alternative? Mu is not equal to 3. That is, this is two-tail test. Okay. Now, if you see in the question, so it is asking at alpha equal to 0.1. So this is given to us at alpha equal to 0, I mean 10%. The question is all the samples they have collected 5 samples from normal mu comma 9, correct? So and what is the sample values? 2.85, 2.40 and 3.3, 2.2 and 3.6. So if you see, when you will reject, what will your test? You will reject your H naught if mod of T is greater than some C or not.
Yes, sir. Yes, sir.
Right? That is something your test will be there, right? Now tell me what will be the next step. See, all of you are done with week 11, so that's why I'm asking again and again.
Alpha is equal to P of.
Finding the alpha.
See, okay, so we will start with alpha basically because alpha is given to us. So alpha is what? Probability that reject H naught when H naught is true, correct?
Yeah.
So what is alpha? 0.1. When you will reject H naught if mod of T is greater than C and H naught is mu equal to 3. So the key thing we have to calculate the value of C here. Okay.
C. Yes, sir.
So if this is the case, and what is the T here first of all? What do you mean by this? T is greater than C.
Sir, x bar minus mu.
Correct. So basically here T is greater than C means you want to check whether absolute difference of x bar minus mu is greater than some C or not. Basically x bar is greater than mu plus C or x bar is less than mu minus C. Correct? If you will expand this
Yes, sir.
right. And in case of one tail test, you will test whether x bar is greater than what?
C.
X bar is greater than C or x bar is less than C, correct? So this is the case. So it will be absolute difference of x bar minus mu greater than C given that mu equal to 3. So what we have to do, basically we have to convert in standard normal variable, right? So what is the value of mu here? 3, correct? One more thing, what will the distribution of x bar? If all xi's are normal mu comma 9, what will the distribution of x bar? It will be normal. Tell me.
Mu comma 9
Mu
upon
comma sigma square by n.
Sigma
9 by
square by
5.
n. So
N.
it's a 9 by 5, correct? So this will be okay. One more thing. Okay, so here you can see x bar is normal mu comma 9 by 5. So to convert in standard normal form, what we have to do? We are normally subtracting the expected value and dividing by the standard deviation, right? So here, if you focus a bit, so already mean has been subtracted, right? So what we have to do to convert in standard normal form? Basically, yeah, tell me what I have to do.
Divide by 3.
Divide with
Pi under root 5.
So I have to divide square root of 9 by 5 because this is the variance. Okay. So what will be the right hand side? This will be C divided by square root of 9 by 5. Is this clear?
Yes, sir.
Sorry to interrupt you, sir. I just want to know, sir, because here also, sir, earlier yesterday also I asked this question, a little bit clarification. You divided 9 by 5 because the number of samples is 5, isn't it, sir?
No, it's not. Yes, it's a number of samples, but I think you should go for the what you can say the derivation behind it. Actually, I think you have missed some session, open session. So actually, if I'm saying x1, x2, xn, this is IID normal mu comma sigma square. Okay.
Mhm.
So I'm interested what is the distribution of x bar. So if you see what is the expectation of x bar, so expectation of x bar means x1 plus x2 plus xn divided by n. So this will
Exactly,
be
sir.
in numerator part expectation of x1 plus expectation of xn divided by n. So if you see the numerator part, it will be mu plus mu plus mu n times mu divided by n. N will get cancelled out. So
Okay.
what is the expectation of x bar? Mu, right? And if you see the variance of x bar, so variance of x bar will be x1 plus x2 plus so on xn divided by n, right? And variance 1 upon n is the constant. If you take n as the outside, it will be 1 upon n square, and inside the bracket it will be variance of x1 plus variance of x2 plus so on variance of xn. And this is sigma square, sigma square, sigma square. This is n times sigma square and n square. So one n will get cancelled out. So you will get sigma square by n. So this is this case. So here I will say x bar follows normal with mean mu and variance sigma square by n. Okay. The same thing we have done here. So sigma square is 9 and n is this. Okay.
Okay.
Now, if you see this case, so what else can I write? I can write z is greater than c by minus, not minus, c, z is greater than 9 by 5, square root of 9 by 5. Or I will say z is less than minus c by square root of 9 by 5 or not. Would you agree with me? This is alpha.
Yes, sir.
Correct? Now, if this is the case, what else can I write? Z is greater than c divided by square root of 9 by 5 plus z is less than minus c square root of 9 by 5. Yes or no? Yes, no,
Yes,
anything?
sir.
Right. So one more thing, if you see from the standard normal curve, right? So this is bell-shaped curve, right? It's a symmetric curve. So suppose this is mean is a 0. If I'm saying suppose this is some value minus a and this is value a, so by the concept of symmetricity in normal curve, so I can write probability z greater than a, this is same as probability z less than minus a or not? Mirror image of this will
Yes,
be
sir.
same
Yes,
as,
sir.
right? So
Yes,
can I
sir.
write, and alpha is given as 0.1. So can I write this part or anything we can convert, whatever the values will be given to us. So basically you can write probability z greater than c by square root of 9 by 5. And this part I can write, this one, I can write probability z greater than c divided by square root of 9 by 5. Now z greater than a is equal to same as z less than minus a, right? So this z less than minus a, I mean this whole quantity I can write as a z greater than this part, correct? So 0.1 will be 2 times probability z greater than c divided by square root of 9 by 5. Yes or no?
Yes, sir.
And this will be 0.1 divided by 2 equal to probability z greater than c divided by square root of 9 by 5. And what is the value of 0.1 divided by 2?
0.05.
0.05 basically, right? And this is the probability z greater than c divided by square root of 9 by 5. So what you have to do, the right hand side you have to convert in abjad form. So this will be, I can write 1 minus probability z less or equal to c divided by square root of 9 by 5. Yes or no? And this will be
Yes, sir.
0.05 1 minus abjad of c by square root of 9 by 5. From here, can I write abjad of c divided by square root of 9 by 5 as 1 minus 0.05, which is 0.95. Is this clear so far?
Yes, sir.
Now, there will be, I mean, here it's not given. I think we need to check. You can check online also, basically. So what is the value of, basically, okay, from here, can I write c divided by square root of 9 by 5 equal to FZ inverse of 0.95?
It is 1.64, sir.
1.64. Are you sure?
Yes, sir.
Yeah. So basically, FZ of 0.95 value is 1.64. That means, sorry, not like this. From table, FZ of 1.64 is
0.95.
0.95. So 1.64 will be FZ inverse of 0.95. Don't worry about the exam. These values will be given to you. So C divided by square root of 9 by 5 will be 1.64 value of this. So from here you have to calculate the value of C, which is 1.64 into square root of 9 by 5. So there will be some value of C. I'm not going to calculate. Okay. So just check this value of C. Okay. And basically you have to check one more thing. You have to calculate the value of X bar from here, right? Yes or no? If you see the test, what is the test? You will calculate the value of X bar from this sample data and subtract your mean mu and just check whether this value is greater than the value of C which you are going to obtain here. Okay. If someone has calculated, you can tell me the values. Then if that value is greater than this C, you will reject. Otherwise, you will accept your H0. Is this clear?
I have a question, sir.
Yeah. Okay, go ahead.
It's not here, it's towards the beginning. So should I ask now or later?
Beginning means where?
Like how you define the test, like reject H0 if mod T is greater than C. So I was looking at the old question paper, trying to see whether, the...
So this is the two-tail test.
Okay.
This is for two-tail test. So you will reject your H0. So mod of T is greater than C means you will reject when T is greater than C, this rejection region, or your T is less than minus C. Okay. This T can change as per the whether you are going to test for mean or you are going to test for variance. All right.
Okay. I am still not clear, maybe because I'm comparing with the question paper and what is given.
No, so in question paper it depends. So if you have been given right tail test, right, then your T will be it will be X bar is greater than C. Okay, if it's left tail test, you will see X bar is less than C. Okay, you can see in the formulas it will be given to you. How what else you have to check? If it's right tail test, you have to only check this part. If it's left tail test, you have to check I mean basically you are going to check the sample mean which you are going to calculate is greater than critical value or not. If greater than that critical value, you will reject. If for left tail test, I mean for this kind of test, if your value of suppose this is minus C, if your X bar is less than, you will reject. Similarly for two tail test, you will see whether it's greater than this or less than this.
So why did we take mod here? In that table, there is no mod, right?
It's mod.
Oh, okay.
Okay. Okay. So is this fine? Rough idea is okay. I think till now I was just discussing the week 11 only. I should move on.
Yes, sir.
So
Sir, the only thing which I need to ask, that you told that this is or in the question itself. A little bit scroll up, sir. You said this this should or there were or, sir, but you or there was or this or the or, but you combine these together, sir.
This one.
Yeah. Yes. Yeah. So how, sir, if this or but you combine this together, sir, probability of this or this. So can you say little?
Okay. I think this is very basic definition of probability. If I'm saying probability of A or B, what do you mean by this?
Probability A plus
either
probability.
A or either B.
That's all. Because there is no intersection in these 2 points, right?
Okay.
Basically, what you are saying, probability of A union B is what? In general, probability of A plus probability of B minus probability of A intersection B, right? So here there is no intersection, so this will be probability of A plus probability of B only. Correct?
Okay, fine.
Yeah. Okay. So let's start for week 12. Okay, all right, right. Till now it's okay, right? I think we have discussed some concepts.
Yes, sir.
Okay, then in week 12, the same thing we are going to discuss, but we will deal with two sample test. Okay, as of now, we have seen for single sample, but what about two sample test? Okay, so in case of two sample test, how will you proceed first of all? Okay, so I think t test has was not discussed in week 11, right?
Yes, sir. It was in week 12.
It's in week 12. So in week 11 only jet test is there, correct?
Yes.
Okay. Okay, then let me start actually. So what is the basically, I will start with the basic formula and all. So we will discuss the t test, chi-square test and two sample test. Okay. Now, so if you see, suppose I'm saying x1, x2 up to xn. This is IID with the normal and mean is mu and variance is sigma square. Suppose I'm saying. So if I'm saying x bar is x1 plus so on xn divided by n. Okay, then what is the expectation of x bar? We have seen this is mu, and what will be the variance of x bar? Tell me. Sigma square by n. Correct? This is something we can cross check. This is the variance of x bar. Okay. What is the sample variance? S square. So this is defined as 1 upon n minus 1 summation I is equal to 1 to n xi minus x bar square. Right? And one more thing we have seen in week 7. I'm not going to do the derivation as of for now because we have to cover. So expectation of s square is same as the sigma square. Okay. This is something we have seen. As expectation of x bar is mu, and in case of variance, expectation of s square is sigma square. So one more thing we have we have seen x bar follows normal with mean mu and variance sigma square by n. Yes or no?
Yes.
Yes, sir.
So the thing is, if we have to deal with variance, right? So the formula for to test for the variance n minus 1 s square divided by sigma square. This will follow chi square with n minus 1 degree of freedom. Okay, let's go with the formula as of now. We will try to do the derivation at the end if time allows. Okay, so this s square is sample variance. This is something you can calculate from here. N is the number of observation. This sigma square will be given to you. Okay, and one more thing, if population variance is unknown, okay, then there is test statistic called, which is defined as x bar minus mu divided by s by root n. This will follow t distribution with n minus 1 degree of freedom. So you can see what if you see the okay, in jet test what we are doing, x bar minus mu divided by sigma by root n. This will follow z, right? Z test. This is z normal 0 comma 1, right? Yes or no?
Yes.
But here sigma square is known to us. In case if sigma square, that is population variance, is not known, it's not given in your question, then you will use t test. That is the some difference we have to keep in our mind. Okay, so t test for mean. So t test is also useful for mean. Likewise, z test. Okay, when variance is unknown to us. If variance is known, you will go for z test, right? If variance is unknown, I will go for t test. Okay, so in this case, what is the scenario? Suppose h naught is given as mu equal to mu naught, and alternative is, let's say mu is some greater than some specific value of mu naught. Then what will be my t value of test statistic? Let's say this is x bar. Okay, then what will be your test as usual? In case of z test, how will you write your test? I am going to reject h naught if x bar is greater than c, or you can see say t is greater than c. Yes or no? Yeah, that is something we are doing usually, right?
Yes, sir.
Yes, sir.
Now tell me, what will be the test statistics? So T minus, I mean, or you can say mu naught divided by S by root n. This will follow T distribution with n minus 1. Or you can say x bar minus mu naught divided by S by root n. Anything, okay? But the thing is, how will you proceed? How will you calculate? So the thing is, if you want to calculate this value C, value of this C, right? That is something usually we are doing, right? We are calculating the value of critical value, I mean C, and then we are comparing whether it's greater than or less than something. So how we are proceeding? We are proceeding with alpha, correct? So probability of reject H naught when H naught is true. So I will solve it in general first of all. So when you will reject your H naught in case of right tail test, basically T is greater than C, right? And H naught is mu equal to mu naught. Okay. The as usual procedure. What is something you do? Okay, if suppose this is Z test, what you will do? You will do T minus mu divided by sigma by root n. Yes or no? In case of Z test, this is something we are doing.
Yes, sir.
Right, but here we are dealing with T test, and in T test sigma is unknown to us, and in the place of sigma what will be sample standard deviation, this will be S. That is the difference only. So in case of Z test we are writing this quantity as a Z, correct? But here I will write this as a T n minus 1, which is greater than C minus, and what's the value of mu? It's the mu naught. Whatever the value of will be given to us, it will be S given root n. Okay, S divided by root n. Basically, if I want to convert in capital F, can I write 1 minus probability T n minus 1 less or equal to C minus mu naught S by root n? Can I write this part, the above equation, like this?
Yes, sir.
Sir, what is T
Yes,
n
sir.
minus 1, sir?
So it follows T with degree of freedom. This is called degree of freedom. Okay, this is just a notation. In case of Z test, we are writing this as a Z, right?
Correct.
This is just a notation for T. It will follow T distribution with n minus 1 when sigma square is unknown. So you can see there is a one difference of sigma only. If sigma is known, you will go for Z test. If sigma is unknown, you will replace with S and it will be Tn minus 1. Okay. And I told you why we are subtracting 1, because of constraint, right? Degree of freedom. And here is one constraint: we don't know sigma. Since we don't know sigma, we have to calculate this sample variance based on the sample data. So this is one constraint, and that's why we are subtracting n 1 from n. So that's why
So,
this is
so like the Z tables we have, so we will have T n minus 1
T,
tables, or
correct. So values will be given to you.
okay.
Okay. Also, one more thing, from the central limit theorem, we know when n is large, all the distribution is going to normal distribution, right? So, sorry, if n is large, let's say 100, 200, something like this. So, even though if you are saying value of t at that value of n, it will be close to Z table, because as per the central limit theorem. Okay. So now can I write 1 minus f of capital F of, okay, in case of normal, we are writing fz, right? Here you will write ft n minus 1, just a notation. Can I write C minus mu naught S by root n?
Yeah.
Correct? Now, okay, so this is basic in general. So from here, you can calculate the value of C. Okay, so basically, okay, next step it will be, you can write ft n minus 1 C minus mu naught S by root n. It will be 1 minus alpha, right?
Yeah.
So from here it will be C minus mu naught sigma by root n will be ft n minus 1 inverse 1 minus alpha,
Is it
right?
sigma or S, sir? You changed it from S
Sorry,
to
it's a S. Sorry, it's a S. Okay. So from here, whatever the value, this value will be given to you. You can calculate the value of C, and you can simply compare the whether it's a greater or less or something, right? Basically, what is the meaning of F? Okay, tell me what is the meaning of FZ? This is CDF of Z distribution, right? I mean normal distribution, correct?
Yeah.
And then what is the meaning of ftn minus 1? This is the
CDF of
CDF of T
Tn
distribution with
with n minus 1 degree of freedom.
correct n minus 1 degree. That is the difference only. Is this fine?
So just one question. So we will
Yes,
be
sir.
given the value of F inverse or we will given the value of F simple.
Okay, suppose I'm saying it's given like this. Suppose f of 1.64 is given is 0.95. Okay, so this means you can write 1.64 as a f inverse of 0.95.
Okay.
Okay, that's what. If you are getting, suppose I'm saying alpha is 0.05. Okay, here. Okay, let's say here alpha is 0.05. So 1 minus alpha will be 0.95. So
Yes,
f
sir.
inverse of 0.95 will be what? 1.64. So value will be given like this. So you can just do the inverse part. Clear?
Okay. Okay.
Let me do one question with this T distribution, and then I will move to the part question next topic. Okay? Do you have any session at 8?
So there is a maths class.
Yes, sir.
Yeah, sir.
Max
We
PS
have
session.
maths, sir.
I think instructor session, sir.
Okay. Okay. Then let's try to finish some part. Okay. Okay. So suppose I'm saying x follows normal mu comma sigma square. Okay. Here sigma square is unknown. Okay. Let's say n is 16. And there is some 16 IID samples of my X. This is given to us. And one more thing, it's given to us, let's say X bar is 10.2. Sample values is not given to us, just a 10.2 is given to us. And sample standard deviation is given to us as a 3. Okay. So question is, if your, let's say null hypothesis is 9.5, and alternative hypothesis is, let's say mu is greater than 9.5, then at alpha equal to 5%, that means 0.05, what will be your conclusion? So that is something we have to do. So if you see, first of all, if x1 x2 xn riid, let's say here, what will be the distribution of x bar here? It will be normal with mean mu. What is the variance? Sigma square by
9, sir.
Sigma square by 16.
sigma square by
16.
Yes.
16, right? But the thing is, okay, let's try to understand this. Okay, first of all, based on this concept, what will be your test? I will reject my h naught if x bar
X
is
bar is
Greater than
greater
C.
than.
now I will proceed with alpha, right? Probability that x bar is greater than c, given that h naught, right? H naught is mu equal to 9.5. Tell me, what should I do? Probability that x bar minus mu divided by what? Sigma we don't know, right? I will do s divided by root n.
Yes, sir.
Greater than c minus mu s by root n. Given that mu equal to 9.5 and alpha is 0.05, it's given to us. So what will be this quantity? This quantity will be
T n minus 1.
n minus 1 is how much? N is what? 16.
16.
16.
Oh, okay.
So it
16.
will be T15
Yes.
greater than c minus 9.5. What is the value of s? It's
3.
3. 3 divided by square root of 16, which is 4 basically. So this is something I can write probability of T15 greater than C minus 9.5, 3 by 4. Correct?
Yes.
Any doubt? Can I write 0.05 as a 1 minus probability T15 less or equal to C minus 9.5 divided by 3 by 4? Yes, no?
Yes, sir.
At the same step, can I write T50 less or equal to C minus 9.5 divided by 3 by 4 equal to 1 minus 0.05, which is 0.95? This part, can I write FT15 C minus 9.5 divided by 3 by 4 equal to 0.95? Yes, no?
Yeah.
So from here, can I write C
minus
minus 9.5 divided by 3 by 4 is equal to FT15 inverse of 0.95?
Yeah.
Okay, let's see some, what will be the value of C? 9.5 plus 3 by 4 ft15 inverse 0.95. Okay, so there will be some values for this you can calculate, and suppose value of C is coming out to be 10.81, for example, hypothetically, because I don't know the exact value of this, it will be given to you. Then will you reject or accept? This is 10.81, and what is the X bar? X bar is 10.2, right? It's given in the question, and this is X bar, and C you got 10.81. Okay,
So we accept it.
Because I will reject when X bar is greater than, but here it's less than, right?
Correct.
So you will accept your null hypothesis. Is this clear?
Yes, sir.
Okay, fine. Then this is for mean. In case of variance, what I will do, I will go for the, I know there is a chi-square test for variance. Okay, so let me quickly discuss the concept, and then we will try to do some questions. Okay, suppose this is IID normal mu comma sigma square. This is suppose scenario, and I'm saying my interest is to suppose my null hypothesis sigma equal to sigma naught, and alternative is, let's say, sigma is greater than sigma naught. Okay, and we have seen one more thing, n minus 1 s square divided by sigma naught square, or sigma square will follow chi square with n minus 1, right? This is something we know. Likewise, you can see the T formula of T test statistics. Similarly, it will be chi for chi square, right? So I will reject, my test will be, I will reject my H naught if I can say S is greater than C or not. In case of mean, what we were doing, X bar is greater than C. Since here we are dealing with variance, or you can say standard deviation, I will say S is greater than C. Would you agree with me?
Yeah.
Yes, sir.
So what will be my T? I mean test statistic. So it will be n minus 1 sigma naught square S square. This will follow chi square with n minus 1. Okay, so basically what we have to focus in our J test, what we are doing, we were converting this part into standard normal, right? Similarly in T test, S by root n. But in case of variance, what we will do, we will try to convert in this form so that I can get the CDF value for chi square. Are you getting the key idea?
Yes.
Let me do in general. Suppose I'm normally we are starting with alpha, which is probability that I will say reject H naught when H naught is true, and probability when I'm going to reject S is greater than C. Correct? Given that H naught. Yes or no? Here I'm rejecting in this case, right? So if you see the formula, okay, let me do like this. What is the H naught? Sigma is sigma naught. This is given. One specific value is given to us. So, okay, to convert in this form, n minus 1 s square divided by sigma naught square, what else I can write? I have to multiply both side n minus 1. Okay, first of all, can I do s square greater than c square? Because my formula is n minus 1 s square sigma square. This is follow chi square with n minus 1, right? Can I do? And s square is greater than c. If s is greater than c, then s square will also be greater than c square, right? Basic mathematics.
Correct.
So if to convert here, I have to multiply with n minus 1 both side.
Yeah.
Right? And divide by sigma square. Yes or no?
Yeah.
Now, if you see, so this will be what? Normally, it become, in case of Z test, T test, it become the standard. So it will be, I will write
Chi
this
square.
as a chi square n minus 1, which is greater than n minus 1 c square. And what is the value of sigma? It's a sigma naught. Some specific value will be given to you. It will be sigma naught square. Correct?
Yeah.
Now, if this is the greater than sign, I want to convert in less than. So this will be chi square n minus 1 less than n minus 1 c square divided by sigma naught square.
Yeah.
Can I write 1 minus f chi square n minus 1 n minus 1 c square sigma naught square?
Correct.
Right? As usual, likewise we did in t test. So what it will be,
So
f
it's still the
chi
value of alpha.
n minus 1 c square divided by sigma naught square.
Is
This will
equal
be
to
1
1 minus
minus
alpha.
alpha. And similarly, we can calculate the value of, so it will be n minus 1 c square sigma naught square f chi square n minus 1 minus alpha inverse, right? Some value will be given to you. So basically, what will be n minus 1 c square will be sigma naught square, sorry, f inverse chi square 1 minus alpha. And I can calculate the value of c square, which will be 1 upon n minus 1 sigma naught square. And basically at the end we have to do the basic mathematics, and you can calculate the value of c square, and you can compute here whether s is greater than c or s square is greater than c square, and accordingly you will
Accept or
reject
reject.
or accept or null hypothesis. Is this clear?
Yeah.
Clear to all of you? Okay.
Yes, sir. Yes, sir.
Okay. So should I do one question related
Yes,
to
sir.
this?
Yes, sir.
Okay, let me do one question, and then there will be only one topic. Then you can go for your mathematics. Is this revision session or as usual session?
Revision session.
Revision session, sir.
Okay.
So it is revision session for by the instructor, sir.
Okay, then okay, I will not take that too much time. Okay, let me do one question. Suppose I'm saying x1, x2, x16. Okay, this is normal mu comma sigma square. Okay, I'm just taking the values. Okay, I'm not taking the scenarios. Okay, I mean I'm just taking the sum. Okay, suppose I'm saying s square is given as to us 3.5 square from the question, and let's say h naught is sigma square is 3 square, and alternative is, let's say, sigma square is greater than 3 square, right? Here sigma naught. So here if you see, we have to test for variance. That means I will go for the chi-square test, right? Basically, I have to convert n minus 1 s square sigma square greater than chi-square n minus 1. All right. So when I will what will be my test from here? I am going to reject my null hypothesis if, tell me.
If your S is greater than
Square is greater than c square.
C.
Yeah, s square is greater than c square,
C
right?
square, yeah.
Okay. So alpha will be what? Probability that rejecting h naught when h naught is true. And rejecting h naught is what? It's a
S square minus S
s
square
square is greater than
greater
c
than
square,
C
and h
square.
naught is, says, sigma square is 9, right? Let's say I'm interested at 5%. Okay. So here it will be probability. Now what I have to do, I have to convert in this. So what I will do,
It's
n
okay.
minus
N
1
minus
s
1.
square. Similarly on other side also, divide by what? Sigma square divided by sigma square, given that sigma square equal to 9. So this part, if you see this left hand side part, it will be chi square n minus 1. So here n is how much? 16. 16 minus 1, it will be 15. Yes or no? I
Yeah.
mean, in the question it's given, we have 16
Yes,
samples,
yes.
right?
Yeah.
So this will be now 16 minus 1, 15 c square, and sigma square is 9. Any doubt? Any doubt till now?
Sir,
No,
here
sir.
here sigma
Hmm.
in the previous problems, generally if sigma is given, we convert that sigma to basically based on the x or t or whatever we are using as a test statistic. Here, do we ever need to use change that sigma?
Where we want?
No, here no, in this problem, in these kind of problems, when we are using it for chi-square, generally sigma is not even given. So we are taking it the value of the
No,
S
no, no.
sample.
That is for t test. Okay. So in t test, you can focus in t test. What is the scenario? Sigma square is not known.
Correct.
Okay. And we have to test for mean. I'm interested for test for mean, not for variance. Okay. Now here in chi-square, sigma square is given to
unknown,
us.
and
No.
and I need to test for sigma square only.
Correct. But this is unknown to us, but there is one hypothetical value, right?
Correct.
That is something we have to use. You can see in case of t test also or z test also, we have to test for mean, right? Mean is unknown to us, but we are going to use this hypothetical value, right? Basically, if you see the definition of alpha, means I'm interested to find that probability where I'm going to reject h naught for the given value of when H naught is true. Okay. So the same case here we are dealing with sigma, right? So now here can I write 1 minus probability to convert in CDF form chi square 50 less or equal to 15 C square divided by 9? Yes or no? It's a greater than sign.
Yeah.
Yes.
So probability I can write probability x square chi square 15 less or equal to 15 C square divided by 9 equal to 1 minus 0.05, which is 0.95. The left hand side I can write f chi square capital F, which represent the CDF of chi square distribution at 15 degree of freedom. Now it will be 15 C square divided by 9 equal to f chi square 15 inverse 0.95. Okay.
Yeah.
So there will be some value for this. So what will be the value of C square here? 9 by 15 into
the
f
x.
chi square inverse and 0.95. So for example, suppose some value you got for C square. Let's say you got C square as a 14. For example, hypothetical value. This is I'm just assuming.
Sure.
Suppose C square is 14, right? And what is your S square?
S square is 3.5.
3.5 square. So what is
Correct.
the square of 3.5? Something 12 point something.
Correct.
Correct. So whether this is greater than C square or not, C square is 14.
Yeah, it doesn't look like. So
right. So it's
we accept it.
Accept as not. That's all. Okay. Is this clear? If S square, which is 3.5 square, greater than C square, then you will reject. Otherwise, you will
accept H naught.
Accept H naught. Okay. So there is one more concept called F test. So should we discuss, or you want to join the?
So tomorrow you can
discuss. We can discuss
tomorrow
in the
you
next
can take,
class.
sir.
Tomorrow I don't think possible. Day after tomorrow we have session.
Sure.
In solve with the session. So what we can do, we can discuss the concept along with question in the slides. That sounds good. And by the time you can cover the lecture video. One more thing for your that maybe that will help you in your midterm exam, right? There is only one question from week 12 of 3 marks. Okay, 3 marks means out of 40. So out of 100, it will be 7.5 marks. So there is only one question from week 12, which is I'm saying I can assure you, which is very basic question, and that is something if you are done with activity questions or lectures video also, and if you are aware about this formulas, I mean this you want to how to interpret this situation, then I can assure you will get the marks for this question. That's the one
clue, hint.
Clue, hint, or you can say whatever you can say. I can assure you. Okay.
Is it choose? Is MCQ or fill in the blanks?
MCQ.
Okay.
MCQ or MSQ, right? That is something you can do by your own. Okay. So why so someone is asking how many questions from week 11. That is something we can't disclose. That is something you have to do. Why I'm mentioning for week 12? Because you have very less time. That's why I mentioned. Okay. Rest you to do the preparation based on the week-wise weightage, which we have already posted on the Discourse. I hope that is.
So tomorrow on Tuesday, sir, you will take the remaining session.
Sorry.
Sir, on Tuesday, sir, you will take the remaining topic.
Tuesday, I'm not sure, but Wednesday I will take. Because Tuesday maybe I'm traveling, but I'm not sure about Tuesday. But Wednesday, Wednesday I will take session. The revision of week 11 and 12 I will take. Tuesday maybe some other instructor will take the session.
Sir, which week has more questions, sir? We'll have more questions.
Prakash, we have posted the week-wise weightage on Discourse. You can check from there. Okay.
Thank you, sir.
Okay.
Okay.
Thank you. Thank you all. Bye.
Thank you, sir.
Thank you, sir.